Now in example 9, you're looking at the marks in a certain maths exam. Okay, and then you're told that the marks are approximately normal, okay, with mean 70 and standard deviation 20. Alright, and then there are 4 parts here that they want you to find. Now in this example, actually all the 4 parts are relatively easy. Okay, but let's quickly go through them. Now, similar to the other distribution question, now very often the first thing that you want to do is to define. Now in this question, no x, no y, no z, no w is given. So you need to say, let x denote the random variable representing the marks of a randomly chosen candidate. Then straight away I can write this down. X follows a normal distribution with mean 70 and variance 20 square. Now, this is a very common student mistake. Now, because the question gives you the information in the form of a standard deviation, sometimes students will write this. X follows normal, mean 70 and variance 20. Okay? You have to read this very carefully. It shouldn't be 20 because this place here is supposed to be filled up with sigma square. So you have to write this as the 20 square. Okay? We're now ready to look at parts A to D. Now, if you look at A says that I have a candidate selected at random and I want to find the probability that he scores more than 60 marks. So I can translate this English into a math statement. Probability that he scores more than 60 marks. See, once I've done this, then straight away I can use my GC to key in the correct numbers and get the answer. Now I can do this because I already know the mean and the standard deviation of this normal random variable. So straight away, answer 0.691. Now I'm going to use the answer for part A for part B and C as well. Now in B, Jane, a student, you want to find the probability that Jane has scored greater than 60 marks and Imran scored less than 60 marks. You have 2 students, 2 independent events, and you want to find the probability that one of them will score greater than 60 and the other one will score less than 60. And because these are 2 independent events, the probability that you want to find is just one of them multiplied by the other. Okay, so in part B, you want Jane to score more than 60, okay, and you want Imran to score less than 60. And this part of the answer is actually your answer in part A, which is 0.691. This part of the answer, probability x less than 60, is just the complement of what you have found in part A. This is just 1 minus 0.691. And then all you need to do is to press your GC to get the answer, 0.213. Done. Okay? Let's take a look at C. Now C says that you now have 3 candidates. Okay, you want to find the probability that one of them score more than 60 and the other 2 less than 60. One of them score more than 60. 2 of them score less than 60. Okay, so it can be more than 60, less than 60, less than 60, or it could be less than 60, more than 60, less than 60, or it could be less, less, more. Okay, so actually there are 3 possibilities here. Alright, so to find this probability, all I need to do is to say that the probability required is probability the first one more than 60, second one less than 60, last one less than 60, then times 3. Or another way to look at it is you have more than 60, less than 60, less than 60. How many ways to rearrange 3 items and 2 of them the same? 3 factorial divided 2 factorial. Okay, this number is 3. So again, I will make use of the answer in part A. This is 0.691. This and this are the same. They are 1 minus 0.691. So you press calculator, answer. Done. Okay? We look at D now. Now, D says this: if 15% of the candidates are graded as A, calculate the least mark for A. Now, to do this part, we need to make one very simple assumption. Okay, we will assume that A is the best grade possible. 15% will be the top 15%. Okay, then I will first of all start by letting M be the least mark grade, the least mark required for grade A. Okay, that means all the marks beyond M, higher than M, will be also be A. So probability M bigger than, X bigger than or equals to M must be 0.15. Okay, and then I think some of you can see where I'm going to do what I'm going to do next, because it looks like a very simple case of inverse norm. Remember inverse norm? I'm given B rather, and I want to find A. The B is my 0.15. The A is my M. So actually, if you compare the two equations, actually the only difference is the sign. But if I can change the direction of the sign, I can straight away use inverse norm to find M. So that's exactly what I've done here. I use the complementary rule, okay, to change the bigger than sign to a less than sign. Then on the right, you have 1 minus 0.15, and this is 0.85. So I can now key in all these numbers into inverse norm to get 90.72866676. And then when I equate it to M, my least mark is 90.7, correct to 3SF.